everyone. I'm here to give you a basic tutorial and walkthrough of some of the simple stuff we can do to do a simple linear model. I threw in some fancy stuff just for fun here, but for the most part, this week's lesson is pretty simple and the skills you'll need in R are fairly straightforward. So I'm starting with our usual housekeeping habit of first clearing everything, hopefully. Sometimes it does, sometimes it doesn't. Cool. We're going to start by clearing everything. Then we're going to go ahead and read. We need the read Excel library, and I'm going to load today's data on unplanned maintenance actions. All right, looks like our data is here, ready to rock. It's complaining at me about it. It seems to constantly complain. No matter how many times I clear the cache, we're just gonna we don't need to keep that as part of our pretty R markdown file. All right, I thought I'd start by going over some different ways that I've found to summarize data. You might like some of these better than others, but here we go. We're gonna go ahead and summarize our data. This is the simple base R way. So if you have no packages and no way to get the packages you want or need, you can simply do, you can tell R to summarize with the command summary. And then because I wanted some standard deviations, I told it I wanted the standard deviations of this data set, UMA raw data. So that's some code for you to get all of your descriptive statistics except standard deviations. I have no idea why R thought, they don't want standard deviations in their basic code. But anyway, this is a basic way to get basic descriptive statistics. It's not terribly pretty, but it works. All right. One package I like for getting descriptive statistic tables, it's fairly new, is this package called vtable. And then we use the sum table command. So I'm going to go ahead and load that library and use that and have it give me, hopefully here, a nice pretty table. Look at that, much prettier. And doesn't like that one. I actually think the exportable table that it creates is even prettier. Let's run that. And it'll show us here, over here in the viewer, you can see the pretty little table it made for us. You can do all kinds of things with the formatting in sum table. So if you're interested in changing and adapting the formatting, the literature on the vtable library is available. So things like changing widths of columns and stuff like that are possible. All right, a way you may be familiar with, because this is what you used last quarter, was using flex table. So for this one, we need R statics to get the summary statistics, though there are other ways. We could probably do it using sum table. I haven't tried it that way yet. I thought I would just replicate what you've done before. We use deployer to reshape the data and flex table to turn it into a flex table. So let's go ahead and run that code. And we get that crazy table. And all sorts of stuff we need and some that we really don't need. All right. So that kind of reviews some of the stuff we've done in the past, and now we get to move on to the fun and exciting stuff for today. So there's a couple of ways we can go about getting correlation coefficients. The first one is by using the correlation command, and we can put the entire data set in there. The second way, we're going to go ahead and just get a table. The second way we do it, we just want those two coefficients. So we just ask it for the correlation of the two variables, pilot experience rating and UMAs, or sorties flown and UMAs, and it'll list those for us. So you have your choice. You can get the whole table, which gives you that information along with some other information, or simply to get them to list the correlations you're interested in. Now, one nice thing to do is to consider making some scatter plots. Oh. Okay. So we'll go ahead and make our scatter plots of pilot experience and UMAs. No. Well, it would probably help if I load the library. ggplot. So I've put in my ggplot. I've asked it to make a scatter plot using geometric point. Told it what my y and x are. I like to set the limits. I like to set limits at the origin at 0 if I can. There's a couple graphs later where I tried to zoom in, so I didn't. But for the most part, I set them at the origin at 0, and then I use the maximums from both pilot experience rating and UMAs to kind of roughly guide where I would put the x and y limits. We label them something meaningful. We give it the whole graph a title. I like the classic theme, and away we go. I hope. There we go. It turned green, and it gave us a really nice little scatter plot. We can do something simple to get similar to get our scatter plot for sorties flown. And again, it gives us a nice little scatter plot. Now we get to the actual analytics part, where we're going to go ahead and run our models. Here we're running 2 linear models. I'm running model 1, UMAs on sorties flown. Model 2 here is UMAs on pilot experience rating. If I just run these, having sort of made them into model 1 and model 2, it's not going to show me much of anything. So I do need to run it with these summary commands to get these nice pieces of regression output. I could show you that if you run simply the linear model, what was that? Right, so if I run just this line of code, the model 1 linear model, blah, 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 run selected lines, it looks like nothing's happened. It looks like nothing has happened because it's stored the information, but it hasn't done anything with it. I can run the actual linear model, but it won't store it. And it also doesn't give me all the useful information that I need to make decisions from the model, like p-values and r-squareds and all of those kinds of things. All it really shows me are the coefficients here. So it gives me the equation, but it doesn't give me all of the information I might want. So instead, I like to run them as models, right, and sort of give them a definition and a name and make them an object. Basically, we're making model 1 and model 2 objects, and then summarize those models. I suggest you come up with your own naming convention. I had one student who named everything and didn't like numbering, and I do find numbering is somewhat helpful. I know that sounds like crazy advice, but I suggest against avoiding numbering. Numbers are your friend. At any rate, You get all of this output. You get all of the information you've seen in the earlier videos, right? You get your coefficients here, but you also get down here your adjusted R squared. You get the p-values for each of the coefficients and these handy-dandy stars to tell you kind of something about the p-value. So if the p-value is really small, you get more stars. To the point that the p-value is kind of large, you get a little period. If you want to put these into a pretty table, I like the package Stargazer. And it gives you a table like this where it has still those statistical significance levels that tell you something about the p-value. So it doesn't give you the p-value itself. It gives you the standard errors in the parentheses underneath, but the stars hint at the sort of level of significance, with more stars being better. It gives you your adjusted R squared that we've been looking at, your n, your number of observations. So it gives you kind of the primary things you need to do analysis, and does it in a pretty sort of table. Again, if you decide you like using the Stargazer package, you can go to the documentation on it, and there's lots of ways to make Stargazer stuff prettier. I do believe Stargazer can also make some summary statistics tables. I just haven't had any luck with it. All right. We might also want to do some more analytics, and one of the key things you might want to be able to do is to be able to store the predicted values of your model. So we talked about using the model to do some predictions. Which we're going to do down here below. But we can go ahead and store all of the predicted values. We can store the confidence interval. We can store the coefficients in particular, so we might want to store, to take the coefficients of the whole model and store the intercept. That's going to be coefficient 1, and the slope here is coefficient 2, so that we can use those later on in our graphs and in our estimates if we want them. We can store the residuals, so the leftovers, which are our best estimate of the error term. So we can store those residuals for other tests later on, and we can estimate the model level confidence interval itself. Let's go ahead and run all of this. I know that was a hodgepodge of things, lots of things you can do, and the only one I think that was sort of interesting was that it gave me why didn't it give me? Oh, it did give me the confidence interval here on the model. So it's giving us the confidence interval for the intercept and sorties flown at 2.5% and 97.5%. So it's giving us a 95% confidence interval for our estimates. A couple more thoughts on that is that we can, probably more useful, is that I can use this to get me a estimate for a specific point. So let's say I want to know at 100 sorties, I put 100 here. I could want to know it at several, so I could do 100, and I could want to know at 75, 80, and 100. 75, 80, and 100. And all of this is going to help me predict the values at those levels. So at the number of sorties flown is 75, what value does the model predict? 80. What value does the model predict? 100. What value does the model predict? It'll also allow me to produce confidence intervals at those values and prediction intervals at those values. Remembering that the prediction interval is going to be wider than our confidence interval because it's the prediction interval for a point estimate rather than for a mean. And our confidence interval, the regression line is kind of like an average response of the y variable to the x variable. So you can think of the regression line as a kind of average. So we're going to want to, so it's going to have a smaller, tighter confidence interval. We're pretty confident that the average responses are pretty tight, but whether any given prediction would fall within a certain range, we have a broader range for that. Anyway, it'll calculate both of those for us. All right, so the confidence intervals, the predictions you get are for 75, 80, and 100 respectively. It gives you then the confidence intervals for each of those, right? The 30, 33, and 42, the lower and upper bounds for 75, 80, and 100 respectively. And down here, it gives you those broader prediction intervals for 70, 80, 75, 80, and 100. Right? So for 75, for example, we fit the model at 30. We always fit the model at 30. And then we have a lower bound here of 24.6 and an upper one of 36.4. All right, I made you a bunch of graphs in class, and I went ahead and gave you some code for them. So if you're interested in the one with the line that's wrong, one with the confidence interval on it, and another one with both the confidence interval and the prediction interval, you're welcome to them. They're here and available for you, and that's the code I've got. So with that, go forth, have fun, run regressions, and we're just scratching the surface of analysis. So thanks for joining me, and we'll see you with more analysis next time.